Okay. So this talk is about, this is something that I built up. So this consensus in a restaurant. Okay. So the story is this: you have a group of people, they gather in a restaurant and they share their opinions about a certain matter. And then they will, and we will see. Okay, so we are interested to see what happens at the end. Yeah. So this is, the setting. So we have a group of m people, 1 to m, and you have, each person has an opinion that I describe it. Okay, so we will describe it by a scalar, xi0 at time 0. Okay, so the ith person has, this opinion at time 0. So what happens is this: each night these people will go to a restaurant, okay, and sit. This is very important. Sit arbitrary and in an arbitrary order. Okay. So here is an example of such a setting. Okay, like first night can look like this. Okay, so we have 6 people. They go to this restaurant, and this introverted guy sits at this table, single, and these 3 guys sit together, and these 2 guys sit together. Okay, so this is how they sit, and here is the dynamics. Okay. The dynamics is this. Okay, this is a hypothetical dynamic. Okay. So each person, like this number 3, will share his or her opinion to the person sitting in his left or right, left hand side person. Okay. So like this 3 will tell about his or her opinion at time 0 to this guy. He will talk about his opinion to the second person, person number 2, and so on. This 4th person, just does nothing, think about his opinion, and this is the way that 1 and 5, will interact. And here's the dynamics part. Okay, so what they do is this: if the jth person, tells about his opinion at this time 0 with ith person, the ith person's opinion at time 1 will be the average of these 2. Okay. So this is a hypothetical, dynamics.
That should be xg.
Yeah,
x2x.
Sorry. For example, here you see 1 and 5 will average their opinions, right? Here you have 10 and 10, so they will be 10 and 10, okay? And 4 person will remain the same, and the rest like this, okay? Believe me, that's correct. Second, at the kth night, they sit in an arbitrary order, not necessarily, the same as the first night, like this, like suppose like second night they sit like this, and again, if at kth night, jth person sits next to ith person, we will have this with j here. So for example, in this case, if second at the third night, their opinion will be like this, just average. Okay, now the question is that do they consent, eventually or not, or under what condition, So if at each night, they sit in a single, alone, they won't consent, So we say that this opinion dynamics admits consensus. Oh no. If this happens, the difference between the opinions goes to 0. So if this happens, can we say that the limit exists? Which is actually true. In general setting. And if it does not admit consensus, does this limit exist or not? Okay, they cannot. We can't have situations that they don't admit consensus. But the question is, if this dynamic basically is stable or not. Okay. Consider this simple case. Okay, you have a big table. Okay, at each night, people sit in one big table. Okay. Now the question is that if they admit consensus or not. Okay. And the answer is yes. Okay. The answer is yes. Here's the proof. Okay. Here's the proof. You basically define this, I don't know, potential function, the opponent function, whatever, which is ensemble variance, okay, like empirical variance times n minus 1 of n. So this x bar, okay, this should be x bar, is just the average of these people, okay? The thing is that you can show that, their average, this variance will decrease, and the decrease is exactly this amount, okay? Now define, this d of k to be just the diversity of the opinions, okay? Like the maximum opinion minus the minimum opinion, okay? We can show that if they sit in one big table, there always exists two people, okay, such that their opinion, okay, diverse the difference in the opinions is at least this amount, okay? So the consequence is this, that v of x0, okay, consider k to be 0, okay? V of x0 is greater than or equal to v of x1 plus this amount, okay? C is, 1 over n squared, okay? And is greater than or equal v of x2 plus this 2, okay? And generally, for any k, we have this, okay? And therefore, this summation, okay, is convergent, okay? Which means that the limit goes to 0, okay? And the limit of the, the opinion divergence at any time t goes to 0, which means that they admit consensus, okay? The minimum opinion minus the maximum, or the maximum opinion minus the minimum opinion goes to 0. So the difference between any two should go to 0, okay? But this was the simple case, okay? How about the general case, okay?
What about the limit in this case?
The limit will be the average, okay? Yeah. So we can show this, okay? This is a cool thing. If we cannot partition the restaurant, okay, into two separate restaurants, such that, we have two subgroups, one S and one S bar, okay, the rest of the people. This S goes to this restaurant, S bar goes to that restaurant, okay? If we cannot do that, okay, from sometimes on, then we will admit consensus, okay? This is not trivial, but you can show with this V function. Yeah?
Sorry, I missed it. How do when two people sit next to each other?
Sorry?
When two people sit next to each other, how do they share the opinion?
Okay, so I showed it here, okay? Yeah, it's the modeling part. Okay, it will be xi at time k plus 1 will be their average. This should be j. Okay. Okay.
This partitioning is this from that time onwards to infinity?
Yeah,
only
yeah,
that means.
yeah. Okay. So if you cannot find this partitioning from sometimes on, okay, then you will get to a consensus. This is a necessary. This is a sufficient condition, okay, for consensus. But You see?
So you're saying sufficient condition is that infinitely often there should be.
Yeah, they should meet.
But-
Okay, which means that so if you pick a set S and its complement S bar, okay, two people from these two groups should sit together, or sit in the same table infinitely often. Okay, that's the message of this condition. Now let me define dynamics to be this. Okay, instead of uniform averaging, weighted averaging. Okay, you have some gamma, and then gamma, 1 minus gamma. Okay, so you do this kind of averaging, and gamma is greater than 0. If you want to get to consensus for any gamma, okay, this condition would be necessary and sufficient. Okay, basically, you can make this gamma small enough, okay, that such that if you don't have this condition, you won't get to consensus. Okay. Now, okay. So what you may ask, what's the deal? Okay. So this is a very hypothetical thing, but let me discuss the general story of double stochastic matrices. Okay. So suppose that we have a chain of double stochastic matrices, which means that they are non-negative matrices. The summation of each row and each column is equal to 1. Okay. And we consider this kind of dynamics. Okay. Xk plus 1 equals to AK times Xk. Okay. And you will see that this dynamics in the restaurant is an example of this dynamics. Okay. For a chain, okay, for a general chain of double stochastic matrices, we say that this chain admits consensus if this summation goes to 0. Okay. Now there's a very cool theorem by Behrouz, which says that if you have a double stochastic matrix, okay, you can write it as a convex combination of permutation matrices. Okay. Now suppose that we have a double stochastic matrix such that the diagonal entries, okay, are greater than some gamma. Okay. Then we can write it as this form, in this form. Okay. Believe me that this is true. Okay. And PL is the Lth permutation matrices. Okay. There are m factorial of such matrices. Let me rewrite this equation, this identity as this form. Okay. Which means that AK is equal to some convex combination of some matrices ML, and ML is this. Okay, gamma times identity plus 1 minus gamma times the Lth permutation. Okay. Now that we have this convex combination, let me do a non-standard thing. Okay. I will define a random process, a random matrix process with this. I say WK equals to ML with probability beta LK. Okay? So I pick a dice with m factorial faces, okay? And I throw it, and such that it comes with probability beta L K at time K in its Lth face. Okay? And whatever happens, I will put this WK equal to ML. Okay? So a sample path of this process can be represented by, it's like this, okay? It's just a chain of these MLKs, okay? And the interesting thing is that such dynamic is the dynamic in the restaurant that I just described, okay? So if your matrices are MLK, okay, like ML is, which is this matrix. So the resultant dynamic will be what? Will be consensus in the restaurant problem. So every sample path of this randomization thing, okay, is a consensus in the restaurant problem. Okay? For example, okay, just to convince you that I'm right, you can write this matrix, this dynamic at time 1, as this, okay? 1/2 I plus 1/2 this permutation matrix. Okay? And yeah, and you see that xk plus 1 in this case would be the average of the expected dynamics. Okay? And okay, so using Borel-Cantelli lemma, you can show that they admits consensus if the summation of ASK, AS is this cross terms between S and S bar in matrix AK. Okay? AS is summation of AIJ such that I is in S, J is in S bar and reverse. Okay? They admit consensus if this happens. Okay, this summation is infinity. Well, if you know what's ergodicity in this setting, such a chain is ergodic if and only if this summation equals to infinity. Okay? Which you can derive from the consensus in the restaurant problem, okay, and Borel-Cantelli. And well, there's one question that I cannot address here, which is a fun problem again, is how to extend this result. You know, here I assume that AIK is greater than or equal to gamma, okay, for any I and for any K. How can we extend it to the case that we don't have this assumption, okay? And that's it.